Welcome to Lesson 6.6. I can graph reflections on a coordinate plane. This one might be a tough one for me to make on the iPad, but we're going to give it a go. So, some vocabulary, of course. The mirror image produced by flipping a figure over a line is called a reflection. This line, so the line that it's flipped over, is called the line of reflection. And a reflection is one type of transformation or mapping of a geometric figure. In math, an image is the position of a figure after the transformation. And we talked about this back in, I believe, Chapter 4 when we talked about dilations, about the original figure would be A, and the new one would be A prime. Okay? So written as A prime. So a little bit of vocabulary there. There is a reflection. A reflection is a type of transformation, a movement of a figure. And the line in which you move it over, a lot of times it'll be X or Y, is the line of reflection. So if I'm going to draw a reflection, you might be able to see these marks better than I can. If I want to copy a triangle JKL at the right on graph paper, so then I'm going to, copy that in. So you could pause here if you have graph paper with you or print out the notes and plot these points. Okay, noticing, and you could make yourself a if you wanted to make one of those lines the origin, if you really wanted, like go right there, so you could plot the points effectively. Then we're going to draw the image of the figure after reflection over the given line. So we're reflecting it over this line, it would seem. So the first step is to count the number of units between the vertex and the line of reflection. So for J, there's 1. Okay, so step 1 is count the number. Count the units from line of reflection to vertex. So J we see is 1 unit. K is 1, 2, 3, 4 units. And L is 2 units. Step 2 is for each vertex we're going to plot the point the same distance away from the line on the other side. So step 2, plot a point for each vertex, same distance to the other side. Bear with my writing. I'm using my finger because this new stylus old stylus, I guess, isn't so much the same as the other one. So if J is 1 to the right, I'm actually going to go 1 to the left and plot my point there and label it J prime because that's the new one. Since K is 4 to the right, I'm going to go 4 to the left, plot my point, label it K prime. And L is 2 to the right, so I'm going to go 2 to the left and label it L prime. Then step 3 is just to connect the new vertices to form the image of JK L prime. So connect to create your new image. Triangle J prime, K prime, L prime. Notice how it's the same congruent figure, just reflected, flipped to the other side, flipped. Okay, so a little bit here. This is kind of a wordy one, a lot of visuals, so you need to really take your time and read through what it's asking you. So this one's saying graph triangle PQR with vertices P at -3, P's at -3, up 4. And Q is at 4, 2. And R is at -1, 1. So I just used this information right here. So I graphed that. On your paper you should also have it graphed. Then it wants us to graph the image of triangle PQR after the reflection over the x-axis. So it's important for us to know which axis is which. So we need to realize that this is our x-axis here. So we're reflecting over this line. And then we're going to write the coordinates of the new vertice. So it has multiple steps. We need to graph, and then write. So again, I'm just going to count up that r is 1 away, so it's going to be 1 away the other direction. So then going over the x-axis, I'm really looking at my y-coordinate. P was 4 up, so I'm going to go 4 down. Q was 2 up, so I'm going to go 2 down. So I plot that point for each of those. Then we'd connect them. So the new coordinates are, so the P coordinates, oops, I need my pen. P's coordinates were -3, 4. P prime now becomes, it's still at -3, but it's now at -4. Q was at 4, 2. Now it stays at 4 and goes down -2. And R was -1, 1. Now R prime is -1, -1. So what you'll notice is that the coordinates of the vertices of the image, we notice that the y-coordinate of the point was reflected over the axis. So the y-coordinate is the opposite, whereas the x-coordinate stayed the same. Because I didn't move anywhere left or right, I flipped over the x-axis, which would be a downward movement. So you can notice that your x-coordinates are all the same, whereas your y-coordinates all became the opposites. So now let's see what will happen if I flip over the y-axis. And notice this is my original. So it looks like B is 2 away, so I'm going to go 2 in the other direction. A is 4 away, so I'm going to go 4 in the other direction. D is 3 away, so I go 3 in the other direction. And C is actually at the origin, so it'll stay there. So my original was A. Ignore that. My original was A at -4, 1. A prime, you'll notice, is at +4, 1. B was at -2, 3. B prime is at 2, 3. C was at 0, -3. C prime is still at 0, -3. And D was at -3, -2. And D prime is now at 3, 2. Again, we flipped over the y-axis, so we changed our movement left to right, whereas it stayed in position up and down. So you'll see now this time the x-coordinate became its opposite, and our y-coordinate stayed the same. So that's kind of something that you can keep in mind for when you're reflecting over an axis, which is going to be affected. Okay, use reflection. So copy and complete the kite shown so that the completed figure has a vertical line symmetry. So vertical line symmetry would just be that you could cut it in half and it would be the same on both the left and the right. So first you're going to have to draw that, and you can just kind of follow along here. So you have to look at each point that's considered. So first you can reflect the half of the kite shown over the indicated vertical line. So we're just going over this line. So we can find the distance from each vertex on the figure just like we did before. A vertex, again, is where two lines meet. So you see vertex here, 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 and here, and here. And so those we can reflect over. So if that is 1.5 away, we're going to go 1.5 to the other side. So it's just really just going to its opposites and then connecting that way. So then you can plot the point that same distance away on the opposite side like we said, and then connect. So this isn't too bad. It's really just going and finding opposites and labeling, making sure you know what the original and which the image, which the prime is. Just being careful with plotting your points, knowing that you move on X first, left and right, and then move up and down on Y second in your ordered pair. So please bring your questions to class and make sure that you're staying focused and doing your best.